Hello everyone, welcome to my presentation on the frequency response of LTI systems. My name is Austin Lynch and this is for the UCSB class EC130B. Let's start off with what is the frequency response of an LTI system? So when the input signal is equal to e to the j omega, so it's a sinusoid with a frequency of omega, the output is a sinusoid multiplied by the frequency response h e to the j omega. This is given in the formula to the right, where the frequency response is the summation of hk e to the minus j omega k. How is the frequency response relevant to discrete time signals and systems? It lets us describe the effect of a system on the sinusoidal input with frequency omega. With this, we can begin to understand and design filters like bandpass and low frequency filters that manipulate and isolate specific parts of the signal. Here's an example. So given the difference equation y of n is equal to x of n minus x to the n minus 1, we want to calculate the frequency response of this system. So from this equation, we can get that the impulse response is delta n minus 1. Applying the equation for the frequency response, that we get that it is the summation of delta n minus 1 times e to the minus j omega n. We get that the frequency response of the system is 1 minus e to the minus j omega. This highlights key concepts about the frequency response, that if we square the frequency response to get the magnitude of it, we get that it is 2 minus 2 cosine omega. This tells us a lot about the frequency response of the signals and how the difference system manipulates the input frequency of the signal. It tells us, for example, that this difference equation that we just analyzed is a high-pass filter. Thank you for listening to my presentation and have a good day.